I shouldn't teach in Spanish because I don't know Spanish. Something like, okay, I mean, hell, I barely know English, so I mostly speak in memes and puns. Welcome! We are pushing from position and how rapidly it changes into velocity and how rapidly it changes. There's no difference mathematically between what we've been doing before and what we're going to do for the next 3 classes. That is to say, the message, the theme, the underlying idea here is, what does it mean to have a value? What does it mean to talk about how that value changes? The rate of change, the slope of a graph is the fundamental idea that we are doing here. Today we are talking about the slope of a slope. How rapidly does a slope change? That's big. Moreover, velocity and his magnitude speed is easy to say. Moving fast, moving slow, moving forward, moving backward, bang. Acceleration does not measure how fast you are, it measures how fast you go faster, or how fast you go slower. That's harder to say, that's harder to think of. In my experience, I would say that well, hell, we did 2 days on position and velocity. We're doing 3 days on acceleration before moving on to things. Acceleration is harder, and I'm giving it more time proportionally. I am going to lead this class, this 3-day section of the module section, whatever, with front-loading problems and how to do them. I'm experimenting and seeing if this helps or hinders. What I normally do is I build up from theory to practice, to solving problems. This section we're going to go backwards. So I'm going to give you, basically, I've given you a homework set and I give you hints for it, bunches of hints. And then next week we're going to go back and dive down into the why. That's not to say we won't do why all the time here. But we're gonna emphasize the how. I can't, however, teach you anything about the how without at least introducing the topic, though. And I can't introduce the topic of rate of change without emphasizing something about change itself. Last week, you may remember, we spent many minutes on talking about what subtraction, what it means to subtract, what it means to have a delta, a displacement from one place to another. I want to spend 5 minutes on emphasizing this again. Google form A is -5 meters per second, changing to -1 meter per second, and increase or decrease in velocity. For dog's sake. Okay, 10 seconds. True. What? Oh, that's the previous class. I mean, people put silly things from time to time, but looks like it's kind of split, not quite evenly. Let me ask you this way. Which is a bigger number, -5 or -1? Am I getting bigger or am I getting smaller if I go from -5 to -1? Google form question B. Am I getting bigger number or smaller number when I go from -5 to -1? Which is greater? From -5 to -1. Increasing or decreasing? Bigger, biggering or smallering? Okay, I still have disagreement here. I'm leading half of the people who were wrong before or right now. I claim that on the number line, let's draw a number line. Here's my initial, here's my final. That's an increase. Anytime I go right on the number line, I am making a bigger number. I am adding a positive number to -5 in order to get to -1. Mathematically, -5 is less than -1. Am I speeding up or slowing down? Just out loud. Google form, question C. Nobody's answering, so put it down. Speeding up or slowing down? If I go from -5 meters per second to -1 meters per second, speeding or slowing? Oof. 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 Holy crap. I ain't touching nothing. Okay. Question. Yes. Yes. That's true. I'm not asking about direction here. I'm asking about the number itself, which is bigger, -5 or -1. And if I've got a velocity of -5, what does that mean compared to a velocity of -1? With a, not velocity, with a speed of 5 meters per second. -5 velocity means I am moving in the negative direction. Every second that passes, I am moving 5 meters. -1 meters per second velocity means every second that passes, I move 1 meters per second downward or leftward or whatever. I'm slowing down. This is faster than this. About 80% of you said that this is faster and this is slower. Turn to your neighbor and discuss. When we have a velocity with a direction and a magnitude, what tells you faster versus slower? What tells you left versus right? Ready, set, go. All right, bunches to do. Bring it together. Thumbs up. I defined velocity once upon a time as telling you how fast and which way you go. How fast? Which way? How fast? Which way? For now, the plus minus shows am I moving up or down. The number, absolute value of the number, the magnitude of the number, shows you how fast. This is fast, this is slow. If I go from fast to slow, I'm slowing down. My velocity is increasing, my speed is decreasing. Velocity is not the same thing as speed. Speed is the absolute value of velocity. So as Velocity goes from negative to less negative. That's a slowing speed. I'm getting less intense. My magnitude is decreasing. Nevertheless, when I go from negative to less negative, I'm adding a number to my velocity. Let's do this exact same mathematical comparison when we're talking about displacement versus the displacement versus distance. What is the sign of my displacement? Positive. What is the distance that I moved? The distance that I moved. Positive. You can't move a negative distance. I ain't never used a meter stick and seen a negative number on it. What's the direction of my velocity, displacement? What's the distance I moved? Positive. Positive. All right, I'm going to move downward. Can you tell me about the sign of my no, 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 no. I'm screwing up this analogy. Screw it. Okay. So one big thing about understanding fundamentally understanding velocity, fundamentally understanding acceleration is understanding what we mean by change. A rate of change ain't nothing but a change divided by the time it takes to make that change. But I want you to think carefully about whether a vector increases or decreases. What does that do to its magnitude? I'm going to graph some accelerated motion on velocity graphs. All four permutations I could think of. About positive, negative. Talk to me, and for the sake of discussion, we'll say this is graph, oh, A is bad because A acceleration. Graph 1, graph 2, graph 3, graph 4, okay? Turn to each other and discuss for a second. Are the values increasing or decreasing? Are the values positive or negative? Talk to each other. Okay, time's up. Values positive or negative? Positive, are you sure? Yes, you should be positive about that. Slope, change. Am I increasing or decreasing? Increasing. Am I increasing or decreasing? Increasing. Here's how to check if you're not sure. Look, let's draw an initial point. Draw 2 points here. I'm gonna highlight 2 points here. That point and a later point. At the initial time, my velocity is that. I didn't draw tick marks on, but screw it. Here's my initial velocity. At a later point on the line, at a time which is further along, that's my velocity. Velocity from here to here. Have I gone up the number line or down the number line? Up. I have increased my velocity. I have increased my negative velocity. I have gotten slower because I am a smaller magnitude of number. I am a slower downward motion, for instance. This Graph represents an object which is moving downward and slowing down. Question. What is decreasing? Be precise. Don't say it. Never say it. It can mean 50 things. So, but ask your question. No. No. This velocity is increasing. Make up a number here. -5, -3. Am I adding to -5 to get to -3, or do I subtract from -5 to get to -3?
The question is, when we say -5, the negative means like in down motion.
Yes.
And the magnitude means the velocity, like the speed.
Yes.
Yeah.
Perfect so far. I'm slowing.
Yes.
Uh-huh.
Quite big.
Yes, my speed is decreasing.
Yeah.
What's happening to my velocity? My v values from -5 to -3, which is a bigger number. Yeah, I'm going up the number line. The v-axis is a number line. I'm going this way along the number line. I am increasing my values of v. Speed is decreasing, 100%. V is increasing. In this case, yeah. Not this case. Here my speed is increasing and my velocity is increasing. Here my speed is decreasing and my velocity is increasing. Speed getting bigger, velocity getting bigger. Completely separate. Yeah. If your velocity is negative and you want to speed up, turn to your neighbor and discuss. How could you have a speeding up motion with negative velocities? Think about it. Talk to your neighbor for 2 seconds, then I'll tell you. Okay, that was supposed to be quick. Time's up. If I'm moving in the negative direction at 3 meters per second, shh, time's up. If you move it the negative direction at 3 meters per second, I can get faster by moving at -7 meters per second. Bang! From -3 to -7, I am getting faster in the negative direction. For instance, I was first moving slow down, I'm moving fast down. That's a decreasing velocity. Negative, getting negativer, decreases velocity, increases speed.
-5, -1, our speed was slowing down.
Yes, absolutely. Speed is decreasing as the magnitude, the absolute value, gets closer to 0. For instance, here, from -5 to -3 to -1, as my velocity increases, slopey uppy, I'm getting closer to 0 velocity. This y coordinate, v coordinate, is 0 anywhere along this line. So I'm slowing down, approaching being at rest. But the numbers I'm adding to the numbers, -5 plus 2 is -3.
1 point are not negative, not negative. The speed was increased.
Yes. You're getting further from being at rest. Here's at rest. Here's slow motion. Here's medium motion. Here's fast motion. The further you get from the horizontal axis on a velocity graph, the faster you're moving. Oh my God, these are such good questions. Yes. The velocity graph on the horizontal axis means your vertical coordinate 0, right? Now, what's the vertical coordinate represent? How fast and which way you're moving. The vertical coordinate on a VT graph, if you're on the horizontal axis, that means your v is 0. You're not moving. Exactly. It does not tell you you're at the origin. Where you are, that's position information, not velocity. Yeah. No, her first, then you. She hasn't asked yet.
basically the starting.
Hey, listen, these questions are really good. You too may have this question, please. Louder, louder.
Speed and velocity have almost like an inverse relationship.
Inverse to me means reciprocal, 1 over something. It is a negative relationship. Yeah. As velocity, as a negative velocity increases, the absolute value decreases. Absolute value means drop the minus sign, right? Increasing absolute values, increasing. Further you are away from zero, the further you are away from zero on a number line, you are increasing the absolute value. In this case, speeding up, speeding up, speeding up. Slowing down, slowing down. As time passes, I am approaching v equals 0, the horizontal axis. Okay, okie dokie pokey pony. I swear to you, this isn't as hard as you think it is. There's a pattern here. Look for the pattern and this can click and it'll never be hard again. Yes. It is absolutely a decreasing velocity. I go from 5 to 4 to 3 to 2 as initial becomes final. Absolutely a decrease. Nope. Decreasing speed. I'm moving in the positive direction, moving up and slowing down. That's still a positive velocity because I'm still moving up. If the v numbers are positive, you're moving up. But smaller and smaller v numbers, closer and closer to horizontal positive numbers, closer to 0 positive numbers mean I'm slowing my motion. Yeah, you see it? Hey! Once you see it, you'll never unsee it either. Yeah, in the back. Wait, say it louder. Yes. The velocity goes up from a negative number to a less negative number. The negative sign tells you moving downward. The number, the magnitude of the number, the 0 through 9 digit tells you fast or slow. If a negative 5 becomes a negative 4, 5 meters per second speed becomes 4 meters per second speed, I'm slowing down. Slowing down, positive, increasing velocity. Yeah. Oh my God, you guys are engaged. I love you. Yes. Perfect. 100%. 100%. Increasing velocities. Decreasing velocities. Right? Increasing, decreasing. Velocities. Decreasing speed, increasing speed. Pick two numbers, take the absolute value. Does it get closer or faster from 0? That's your speed. Pick two numbers, draw them on a number line. Do they go right or left? That's your velocity change. Absolutely. I mean, anything along this slope, if the slope is positive, whether that be this part or this part, an upward slope, increasing velocity. Look at any 2 points along the number line. I'm going up the number line. From initial to final, I'm increasing velocity. So anything that looks like this, anywhere like this, increasing velocity. Anywhere like this, decreasing velocity. If the slope is negative, the velocity is decreasing. But the absolute value of velocity is decreasing if I point toward 0. Here's slowing. Here's speeding. Up. Slowing down, speeding up. Turn to your neighbor and express. Muy importante. Okay, time's up. Two more questions, and then I'm moving on. Give them to me, baby. Come on, come on. Give me your questions. Come on. I hunger for questions. I'm a question vampire. Yeah, please. I mean, -5 is a number. Look at the absolute value, the magnitude, just the numeral. Yes. Say, what do you mean? Say again? Mhm. If you're drawing a VT graph. What if you're drawing an XT graph? How do we see velocity on a position graph? Slope. How do you see speed on a position graph? Steepness of slope, right? Positive, if I'm talking position, positive velocity, negative velocity, slow velocity, fast velocity. Yeah? If he's steep, it don't matter if he's going up or down. Positive 10 meters per second is a steep position graph. Negative 10 meters per second, steep negative slope on position time means fast. You got to be able to distinguish here. What am I graphing? Somebody shows you a graph without labeled axes. It says, am I speeding up or slowing down? You say, bullshit. I don't know. No one can tell. Dr. Tucker can't tell. Richard Feynman couldn't tell. Unless you tell me what you're graphing. Yeah? And you got to think about, what does this represent? Okay. Wait, one more question. Last question on this, on changes and magnitudes. Not in here, nothing seen. Okay. Blah, 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 blah. Acceleration is the slope of velocity. I define acceleration as the slope of velocity. If your velocity is increasing, slope is positive. Acceleration is positive. If slope is decreasing, slope is negative. Acceleration is negative. Bam, that's it. That's all there is to know about acceleration. A is the slope of v. Change in velocity divided by change in time. It's the slope formula. Acceleration, positive or negative? Positive. Acceleration, positive or negative? Positive. Acceleration, positive or negative? Acceleration, positive or negative? Okay, positive acceleration means speeding up, right? No! Positive acceleration, positive slope, getting closer to 0 meters per second. Write this down, big bold letters. Negative acceleration does not mean slowing down. Positive acceleration does not mean speeding up. Negative acceleration does not mean slowing down, and positive acceleration does not mean speeding up necessarily. Can, but you cannot conclude that you are slowing if your acceleration is negative. I will ask you a question like this on the exam. Think about the why. What are the slopes? Positive, not increasing. Increasing means curvy. The slopes are positive. Am I getting faster or slower? One faster, one slower. What are the accelerations, positive or negative? Both positive. Tilty uppy, acceleration positive. Tilty downy, acceleration negative. Accelerations are positive, but one's fastering, speeding up, and one is slowing down. Huh? You see? Turn to each other. Yeah, question first. Uh-huh. Uh-huh. What is going to be positive? Be precise. If the line on what graph? But I haven't talked about acceleration graphs. These are velocity graphs. We'll talk about them in a second. Okay, again, the point. Will you bring this up in 3 minutes? Okay. The point I am making here, positive acceleration does not mean speeding up, negative acceleration does not mean slowing down. It's what we just said here, except applied to slopes instead of just discrete point changing. Velocity increases regardless of whether that's speeding up or slowing down if the velocity numbers go up the number line. If velocity values are going up the number line, that's a positive acceleration. And it doesn't mean speeding up or slowing down. Vice versa for negative slopes, negative changes of velocity. Yeah, question? Yes, always. Always. Yes, always. 100%. Very good. Look, these are the speeding up ones, right? What can you say about the slopes and the values? What's in common here? The sign is the same, right? These are the slowy downy ones. What could you say about the signs? Negative values sloping positive, and positive values sloping negative. What can you say about the signs? They do not match. If velocity and acceleration are both positive numbers, if velocity and acceleration are both negative numbers, if they both have the same sign, that's speeding up. I'm Richard Nixon right now. That's speeding up. Yeah.
Position time graph, the slope would get us the velocity.
Yes.
Steepness would get us the speed.
Yes.
What would happen in the VT graph? Like what would the steepness get us?
The value, high number, low number. Or I should say, number far from horizontal is a steep position graph. Number close to horizontal is the shallow. Because what does shallow mean? It means small value of velocity, small magnitude of slope. That's what steepness is, absolute value of slope. So steep slopes have steep position graphs have big slopes, which is big speeds, far velocities from horizontal. Okay. Again, I want to say the last thing again, because this can be super helpful in helping you avoid mistakes. Position and velocity, same sign, speedy uppy. Position and velocity, opposite sign, slowy downy. Later, we will talk about position. I should have been saying acceleration for every goddamn step. If velocity and acceleration are the same direction, whatever that is, you're going to speed up that velocity. If velocity and acceleration oppose each other, whatever that is, positive, negative, positive, that's a slowy downy, because that acceleration brings you closer to zero, closer to at rest. Later on, if we are lucky, and I feel lucky, punks. Do you feel lucky, punk? Okay, it's a movie. If position, velocity and acceleration can also be at right angles, and we will discover that what happens when your velocity and your acceleration are at right angles is circular motion. We're not doing that yet. You're welcome. Okay, I want you to turn to your neighbor and express the idea. If velocity and acceleration are in the same sense, have the same sign, that's a speedy uppy. If they oppose signs, that's slowy downy. Ready, set, go. Tell each other. Okie dokie, next thing. She asked about acceleration graphs. Let's talk about acceleration graphs. I didn't know say that. Ow. Absolutely. Absolutely. Acceleration is positive is different than acceleration is increasing. Velocity is increasing, but this line has a constant slope. Positive slope. Yes. Yes. No. Acceleration is not change in speed per time. It's change in velocity per time. Acceleration is positive because I'm negative getting less negative. That's an increase along the number line. Acceleration graphs? Do you want to ice your brains first? Tough. We ain't got time. Speed up in the positive direction, move steadily at the positive direction, slow down in the positive direction, turn around, move down at an increasing rate. You see that? Do you see that? Positive direction, upward, downward, fast, slow. Huh? What we just been saying? I'm speeding up in the positive direction, upward. I'm getting upward and upwarder faster. I am still going upward. Velocity is steady, positive, still going upward at a constant, steady rate. I am still going upward. V's are positive, still going up, but I'm slowing down, slowing down. Turnaround point. I'm at my highest physical location. I've been going up this whole time. I'm about to turn around and go down. I am speeding up while going in the negative direction. Yeah? Yeah. Now let's turn this into acceleration. Is the slope increasing or decreasing? Constant! You saw through my little trick. Constant acceleration. The slope is constant. The slope is positive if you going up, if the values of velocity are going up, but he's still a line. This is even straighter than I am. Wait, did I already make that pun in this section? I forget, whatever. The slope is a constant positive. What is the slope here? Constant 0. It's a very well-known constant. What's the slope here? A constant negative. This is going to be a piecewise constant function in the acceleration land. Shoop. A doop. A doop. There. Bang. Done. Here's my acceleration graph. My slope is 1 meter per second upward. My slope is 0 meters per second. My slope is negative 3 meters per second Can you do this? Yeah. Yes. Yes. If you have a changing slope, if you have curvy velocity graph, then the acceleration graph will not be piecewise constant. Sure. I'm not going to give you accelerations that aren't piecewise constant. Maybe that's easy. However, I will give you position graphs that are not piecewise constant. I am going up fast. I'm going up medium. I am going upward. No, I'm not. I'm at rest. Position graph. I'm going downward slowly. Fast versus slow. Steepness of the pencil. Right? Upward versus downward. Tilty pencil up, tilty pencil downward. Do you see that? Position graph. Don't forget. Don't forget the simpler one. Going up anytime I'm sloping up. Going down anytime I'm sloping down. Moving fast, moving slow. How is my velocity changing here? Big positive, medium positive, 0, medium negative, big negative. How is my velocity changing, increasing or decreasing? No, always decreasing. Acceleration here is always negative. If I go from a big velocity, 5 meters per second, to 4 meters per second, to 3 meters per second, that's a decreasing velocity and decreasing speed. A decreasing velocity, negative acceleration. Don't just look at the slope. The slope of position is velocity. I'm looking at the change in slope. Is my slope getting slopier or less slopey? This is getting the slope is decreasing, a positive number getting less positive. Then a zero number getting negative or a negative is still a decrease. Cuppy uppy, positive acceleration. Negative number, negative slope, less negative slope, less negative slope, zero slope. I have added to the slope. Negative slopes become less negatives. Then positive slopes become more positive. All that's positive acceleration. I am not going to ask you to calculate accelerations based on curvatures. That's calculus. I am going to ask you to identify, am I accelerating positive or negative based on these? You could tell the stupid, silly way is if the cup would hold water, that's positive, yeah? Acceleration is positive, curvature is up. Acceleration is positive. If the cup is dumping the water out, that's a negative acceleration, negative curvature. And if the cup is not a cup but a straight line, zero acceleration on a position graph. Let's solve some problems. I've got a lot of problems. Yeah, last question on this. Listen.
If the graph is in fourth quadrant,
Position versus time down here, yeah. No. If graph is in fourth quadrant, that means x is less than 0. Position, negative. I am below the origin. Doesn't mean you're moving up, doesn't mean you're moving down, doesn't mean you're moving faster, doesn't mean you're moving slower. If x is negative, third or fourth quadrant, that just means you're down below the origin.
if that object is first graph, it also shows it was like basic.
At this instant, the object has passed the origin, passed the x equals 0 point. It is located at the finish line.
What happened now?
It is going below the finish line. So here's an example of this object. I'm going to make my hand do this. I'm going to make my hand move upward quickly, then slow down, then move downward quickly, and then slow down, and then keep going down. I shouldn't have hit it. The instant my hand passed or hit, accidentally the table is here. Notice I was still moving. I still had a slope. No, 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 no. No, he's speeding up, right? The slope is getting intenser. The position slope, the velocity is getting intenser negative. Yep. The height does not affect the curvature one bit. It also doesn't affect the slope one bit. Right? At this instant, slopey downy at this steepness, at this same instant, this slopey downy at the same instant. This is just motion above the tabletop, motion below the tabletop, moving as fast and in the same direction at each instant, accelerating in the same manner. I love you guys. Your questions are so delicious. Problem. Reaction time. What's reaction time? I have a reaction time before hitting the brakes. What's that mean? What does that mean in terms of the velocity, acceleration, position, blah, 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 blah of my car? How long it takes what to get to zero? What does reaction time mean? Tell me about, if I've got a reaction time of 1 second, the amount of time I need for information to hit my brain and me to start to do something. If I have a reaction time of 1 second and the car in front of me slams on their brakes, for the first second after that starts, I am not going to be able to put my foot down. Reaction time means dead time for any changes you want to make. Braking reaction time is how long you're moving at steady speed, steady velocity, really, before you're able to react to it. What about at the stoplight? Light turns green. The instant the light turns green, are you moving? No. Takes some milliseconds or seconds for you to realize light is green and put your foot down. That's your reaction time. If someone is driving and sees something jump out in front of their car, do they instantaneously start braking? No, they have a reaction time. Let's pretend your reaction time is 1 second and initial velocity. This is typical for a car equals 20 meters per second. That's what, 45 miles an hour? 1 second, not unreasonable. I will also tell you magnitude of acceleration. Is this acceleration actually a positive vector or a negative vector? Positive velocities are going to go which way? I'm braking. Did I tell you that? I didn't write that down. You slam on the brakes, and I'm telling you that your velocity is changing by 6 meters per second every second. Takes you 2 seconds to slow down from 12 meters per second to a stop. Tells you 3 seconds to slow down from 18 meters per second to a stop. Acceleration is negative in this case, because if I'm moving in the positive direction, positive 20 meters per second, and slowing, presumably your brakes slow you down, hopefully, then that's an acceleration in the opposite direction. Good. Okay. Now, the question is, if I have a 1 second delay before I could do anything, then I apply that 6 meters per second squared acceleration. Can you find how far I go before I am at rest? Draw a graph and argue with each other. This will take a minute.
Can we get the total time?
That's part of the problem. What I'm asking for is the total distance, but you can deduce the total time. You can figure it out based on what's given. Be creative. Next class, I think, we're going to learn a set of equations that lets you do this automatically. For now, you have to use creativity.
I don't. That's why.
Don't use them. Don't use them yet. If you know the kinematic equations, screw them. Not now. Find how far you go before you break to a stop. Before you come to a rest. Okay, I do not insist that y'all are done. This is your first time. This is your first problem with a bunch of numbers in. However, I would hope that you got the first part. How far do you go in that for a second? 20 meters. Do, 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 do. If I make a VT graph, well, that's not a solid line. Wait, hold on a second. If I do draw that in, 20 units high, 1 unit long, 20 meters per second times 1 second is 20 meters. I could also associate this with the area. Very curious. I'm going to sketch this in for shits and giggles and identify this here as I go. Delta x here is 20 meters. What happens if I moved with what happens if I had a reaction time of 2 seconds? How far would I go? Oh, look, the base would be 2, the height would be 20. It's as if multiplication is like finding an area or something. Okay, now here's another question. I start at 20 meters per second. I change my velocity by 6 meters per second per second. What can I deduce? The time for what? Be precise. The time it takes to stop. How do you do that? I want to write down what I said earlier about acceleration being the slope, the delta v over the delta t of velocity. Acceleration is how much velocity is changing per time interval. How can I solve this equation for time? Well, I can use the principles of algebra. I can multiply both sides by t. And I'm going to write this as final minus initial. Wait, what's the final velocity? And then if I want delta t, yeah, plug in numbers. What's the initial? 20. What's a? Negative 6. You actually plug in numbers, you can use these vector quantities. Remember? Because we deduce that if you're slowing down from a positive velocity, that acceleration is opposite sign, yeah? What's 26ths? 3.3? So does that mean that I draw a line like that? Yeah, everyone agree? No! What have I screwed up? 1 second reaction time means I am not starting at 0. If I start at 1 second and it takes me 3 1/3 seconds to change my motion by some amount, here is 3.3 seconds of slowing down, 3.3 seconds of accelerating, right? From 1 to until 4.3, that's when I'm accelerating. Yeah. Yeah? Yeah. Oh, yeah. Oh, yeah. Okay. Now, the last part is the interestingest part, the new part. Yeah, question first.
1 second. Shouldn't we start from the second? Like,
How many seconds does it take to go from 0 to 1? It's not 2. How many seconds does it take to go from 0 to 2? That's 2 seconds. If I waited until here, I have waited 2 seconds. 1 is not the beginning of the number system. 0 is. Okay, so now comes something interesting. If I change my velocity smoothly and steadily, you cannot just say final velocity times time equals displacement. What's the final velocity? What's the time? 3.3 seconds of slowing down? Yeah. 3.3 times 0 is 0 displacement. What? No. No. You can't just say any old velocity times time is displacement. What you can say is average velocity times time is displacement. And your average is just simple initial plus final divided by 2. What's the average from 20 to 0? Average of 20 and 0? This should not be a tough calculation. 10. 0 plus 20 over 2. Okay, so 10 meters per second is the average velocity. How far do you go in 3.3 seconds if you're averaging 10 meters per second? 33 and a third. Oh, I'll just round it. What's the triangle area formula? Half base times your mama's height, yeah? Thank you. You get an A. I mean, if you earn it. 1/2 of 20 times 3.3? Very suspicious. As it turns out, geometric area on a graph can always tell you the accumulated product. If you multiply a constant v times a constant t, that's like multiplying base times width, height times width of a rectangle. But if you've got a changing the velocity as time passes, you could still draw a graph, find the area, and that's still the accumulated displacement. Magical. That's actually calculus in disguise. We are never going to use anything that requires calculus manipulation formulas, but this idea is deep and profound and goes down. You can follow that rabbit hole down, follow that rabbit down rabbit holes. Total displacement then? You got it. Okay, so if you know the average, well, initial and final velocity, you can get an average. Everyone knows the average formula, right? Right? You learned that in first grade, right? Average formula, average of two numbers, add them and divide by 2. Okay, if you could find the average velocity, then you could find the displacement during a time interval. And if you want the time interval, you can get that from this. I've told you how to solve the hardest problem on the test. On the, well, test 2, but we're not taking the test yet. Hardest problem on the homework. Now, a couple of easy things. This was brain. Now let's do something less brain. What Google question are we up to? D, is that all? Ugh. Okay, D. How many seconds is 1,000 milliseconds? Google form. E, how many milliseconds is 1 second? Ah, hell, one more. F, how many seconds is, oh, for dog's sake. How many, no, no, no. There, that's what I wanted to write. How many seconds is 1,000 millis? How many millis is 1 second? And how many seconds is 2 millis? I will remind you that milli is thousandth. Killa is thousands. Okay, this is important. Don't go yet. The answers. Millas means thousandth. If I have 1,000 thousandth, how many things do I have? 1,000 divided by 1,000. 1,000 divided by 1,000 pieces is 1. If I have 1 unit, how many thousandths of a unit do I have? Not 1,000th of a millisecond. 1,000th of a millisecond goes by the name of 1 microsecond. A fraction of a milli is a very small number. You need a lot of millas to add up to a whole. How many S is to ms? 2,000ths. 2 divided by 1,000. Wait, can I calculate that? 2 divided by 1,000 is the same thing as shooping, duping, duping 3 times. Where's the decimal? Not, no, not, shooping, duping, duping is not that many there. Hmm? Hmm? 2 milliseconds, 0.002. Shift the decimal 3 times for good luck. Okay, done, 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 done. The 3 o'clock class, I gave additional hints on a couple of additional things. As you see, I have misunderestimated the number of minutes in the class. I got the milli to minutes question obviously confused. So if you struggle with something, I've given you foundations. I've given you basically the answers for half of them. If you struggle with the other half of the homework questions, the videos are posted on YouTube. You all know where to find them, yeah? You can get other hints. The first half of the 3 o'clock recording, the first half is the foundations. You can watch that again if you prefer those words. Maybe I explained it in a slightly different way. Maybe if you're having trouble with the foundations, go to that as well. But it's the second half of the 3 o'clock class that gives additional homework hint. I will stick around up here to answer final questions. Otherwise, adios. Don't forget to do your Friday quiz, y'all.